These type of arrangements of impedances or resistances, or like if it is an impedance, it is a mixture of resistance, capacitance, inductance, whatever. This is called delta connection, this one, because it looks like a delta, Greek letter, capital delta, while this one is called a Y connection because it looks like a Y. So now these connections can be interchangeable. Sometimes for the convenience of solving the circuit, we need to convert a delta connection into a Y connection or vice versa. So how to do that? I will just talk about the conversion formula, which is like this. So if I want to do a delta to Y, so while I am transforming, these are three nodes here, N1, N2 and N3, and the same nodes will be here, N1, N2 and N3. It's very important in terms of response to the remaining part of the circuit that it doesn't change. The overall effect of impedance is the same as what it was for delta will be the same for Y, or if it is the conversely changed, it should be the same for Y to delta. So anyway, from delta to Y, so this is R1 here, R2 and R3. So R1, which is connected from node 1 to a neutral. Y will have a neutral. Now this one, and here is N1, which has RA and RC connected to it. So RA is connected here and RC is connected here. So what has to be done is RA and RC goes on top on the numerator. In the denominator, it's always sum of the three. So like that, RA, RB, RC. Similarly, if it is R2, I will keep using the red one, R2, which is connected at N2. So if I look here, N2 is here, which has RA and RB connected to it. So RA and RB, this is how we can remember. And then again, the denominator is the same, RC. And then R3, finally, that one is connected to node 3. So R3's value will be N3 here is connected to RC and RB. So RB and RC, RA plus RB plus RC. So the denominator is common everywhere, and the numerator is what, whenever we are talking about a node here, in delta, two elements were two resistances or impedances were connected to it, so the multiplication of the two will come on top. That's how it is. So this is delta to Y. So we have a Y delta network. We want to convert it into Y, the equivalent value, Y values. Now if I want to do the Y to delta, I will just erase this part instead of erasing the whole thing. So basically I want to do Y to delta now. So I have this one, I want to convert it into this one. So if I want to know what is the value of RA, which is between node N1 and N2, so RA, here the top one will always like this, will be always like this, R2 R3 and R3 R1. This is the common numerator in all three of them. That will be the denominator will be, since it is RA and connected between node N1 and N2, so it will be just the opposite one, which is R3. Similarly, RB, so RB, which is connected between N2 and N3, so N2 and N3, So the opposite one is R1. So it will be R1 here, and the same numerator that's on the top, it's the same thing. Similarly RC, which is connected between N3 and N1, N3 and N1, so opposite is R2. So it will be R2 here, and here is the same thing, R1, R2, R2, R3 plus R3, R1. That's how it goes.